So dear students, it's time to start a very important chapter in chemistry. Acids, bases and salts. Now see students, in chemistry we have to study a lot of different compounds. Now imagine how hard it would be to study all the compounds separately. There are a lot of compounds, right? Now what is done is that compounds are divided into different groups. And we study these groups because it's easier this way, like acids. Acids is a group of various compounds. And properties of these compounds are very much similar to each other. Then comes bases. Properties of these compounds in this group also match more or less with the other compounds in this group. Okay, similar is the story with the salts. So these three are actually very important groups of compounds. Actually, acid students are extremely important. In our day-to-day lives, acids play an important role. Okay. So, if you go to chemistry lab, you will find acids everywhere. Then bases and salts. They are also very important compounds. So students, by the time we end this chapter, you would have understood that chemistry is really a very interesting subject. Okay. And there are a lot of practical applications of it. Many people think there are no practical applications of chemistry, but that's not true, students. At the same time, you would have understood what are acids, what are bases, and what are salts. So come on students, let's start. See here students, I am writing some names of compounds over here. Also the formulas are over here. They are very important. You have to remember them. HCl, hydrochloric acid. This compound, students, from the name itself you can say that it's an acid. And HCl is its formula, H2SO4. This is sulfuric acid. Sulfuric acid, very important compound. HNO3, this is actually nitric acid. Nitric acid. So students, from the name itself you can understand that all these are acids. There are many acids. We will learn about them as we proceed further in this chapter. Now, we want to see, students, why these compounds are called acids. What is the similarity between them? They all are put in one group, so what is the similarity between them? One thing you can understand that you can see hydrogen atom here, right? So students, what happens is, let's discuss HCl, hydrochloric acid. This is basically a gas. At room temperature, this is a gas. But if we dissolve this in water, now see, what should I write here? After HCl, S, L, G, aqueous. We have studied all this in previous courses. This means it's a solid, this means it's a liquid, this means it's a gas. And writing aqueous means we have dissolved it in water. So basically this is gas. So what we do, we dissolve this in water. So we will write aqueous. When we dissolve this in water, what happens is the two ions with which this is made up of, these two ions get separated, somewhat like this. Now you know, students, that the hydrogen ion carries one positive charge and chlorine ion carries one negative charge. So here hydrogen ion is formed or dissociated. So I'm saying this process you might be knowing, it is said to have been ionized. The HCl has ionized or dissociated. Okay students. Then what happens is, this hydrogen ion, after reacting with a water molecule, makes a different ion, like this. See, this was the water molecule H2. Now this hydrogen ion gets attached to it, forming H3 plus O. Because there is a positive charge on this, hence it's an ion. And students, this is called hydronium ion. This thing that we saw here doesn't only happen with HCl, it happens with all the other acids as well. And the compounds with which this doesn't happen, we do not call them acids. So which compounds are called acids? Acids are those compounds which, when dissolved in water, produce hydrogen ion. And that hydrogen ion, after mixing with water, creates hydronium ion. Many a times it will happen that you are told that acids on dissolving in water produce hydrogen ion. Only this much will be said. It has to be understood that this hydrogen ion will react with water and form hydronium ion. The other acids also react in a similar way, like for example nitric acid. Let me tell you about it. For it, we write HNO3 aqueous. So it has been dissolved in water. We get H plus, which is an hydrogen ion, plus NO3 minus. And this hydrogen ion, students, will have the same reaction and form hydronium ion. Sulfuric acid. Same thing happens with sulfuric acid. Here space is little. See, this is sulfuric acid, H2SO4. Its aqueous solution, meaning when it is dissolved in water, you see here we will get two hydrogen ions. Why? Because there is H2. So two hydrogen ions are formed plus sulfate ion. So sulfate ion has -2 charge. So there two hydrogen ions will react with water molecule and will produce hydronium ion. So all the acids have this property that when they are dissolved in water, they produce hydrogen ions. And the compounds which do not behave in this manner, we cannot call them acids. Now let's discuss some other compounds like NaOH. Its name is sodium hydroxide. Sodium hydroxide. KOH. Its name is potassium hydroxide. Students, CaOH whole 2. This is calcium hydroxide. So students, these are some examples of bases. These are bases. Those were acids, and these are some bases. There are many other bases. Some of the important ones we will discuss in this chapter. Now see, what are the properties of bases? See, NaOH. This is a solid at room temperature. This is a solid at room temperature. When we dissolve this in water, NaOH, when we dissolve this in water, meaning when we make an aqueous solution of it, then what happens? This has two ions, one sodium that separates and one OH ion which has negative charge. This gets ionized and dissociated into these two ions. OH ion is called hydroxide ion. Hydroxide ion. So these kinds of compounds which when dissolved in water give hydroxide ions, they are called bases. The ones which give hydrogen ions are called acids, and the ones which give hydroxide ions are called bases. Okay, we call it base. Like KOH. If we make an aqueous solution of this, what will happen? K plus and OH minus, hydroxide ion. Calcium hydroxide. Then if we make an aqueous solution of this, then calcium plus 2, and here two hydroxide ions. So two hydroxide ions will come. So students, you might have understood the properties of acids and the properties of bases. Okay. Now it's time for salts. What are salts? Now we will see little bit later. We will see in detail. I'm writing some examples of salts here. See, NaCl. This is a compound that is called sodium chloride. It is called sodium chloride. This is a common salt which we put in our food and eat. Copper sulfate, CuSO4. This is copper sulfate. KNO3, potassium nitrate. Potassium nitrate. These are some salts. There are many more salts. We will see as we proceed. What kind of compounds are salts? Listen carefully, students. HCl. What is this? This is basically an acid. Okay, now see. How will NaCl come from HCl? How? If we can replace this hydrogen with sodium, then NaCl will come. H2SO4. This is an acid. How can we get copper sulfate from this? You think about it. If we replace the hydrogen with copper, then copper sulfate can be obtained. Then KNO3. HNO3. It is an acid. If we replace the H from it with potassium, then KNO3 is obtained. So students, salts are such compounds which can be produced by replacing hydrogen by an element in an acid. Suppose there is an acid. If we replace the hydrogen with a metal, the compound formed in this way is called salt. So students, we can write that salts are compounds obtained by replacement of hydrogen from acid by a metal. Salts are compounds obtained by replacement of hydrogen from acid by a metal. The hydrogen in acid, if that is replaced by a metal, then what do we call it, students? Salt. So students, we have seen what are salts, what are bases, and we have also seen that what are acids. We can write the definition of acid and base. See, acids are compounds which give hydrogen ion in aqueous solution, like we saw, and bases are compounds which give hydroxide ion in water solution. Now see students, some acids and bases are very strong and some acids and bases are very weak. Now what is the concept of being strong and weak? That is what we want to see. Now see students, I have written some names of acids here. Some of them you have seen earlier, some of them are new. See hydrochloric acid, I have written. You can see H2SO4, this is sulfuric acid. Nitric acid, HNO3. Hydrobromic acid, HBr. Carbonic acid, very important acid, carbonic acid, H2CO3. Phosphoric acid, sulfurous acid, acetic acid. Okay students, these are some examples of acids. There are lots of acids. Now we will see especially sulfuric acid and sulfurous acid. Sulfurous acid is not very important. Still we are focusing on this because people tend to confuse between sulfurous and sulfuric. See, sulfurous and sulfuric. The formula of sulfuric acid is H2SO4. The formula of sulfurous acid is H2SO3. Okay, so do not get confused. Now see students, what happens? For example, take this hydrochloric acid. We saw that the aqueous solution of hydrochloric acid gets ionized and forms hydrogen plus and chlorine ion. Right? Okay. Now see the last acid in the list and what happens with it. The same thing will happen because it is also an acid. And the same thing happens with acids when you dissolve this in water. Right? It will get ionized and make CH3, COO minus. This ion will be formed and one H plus ion. This will make H plus ion too. So this is an acid. Now see students, there is a difference between these two. In HCl, that is hydrochloric acid, and in this acetic acid, there is a difference. So what's the difference you see? All the molecules of HCl we put in the water, every last one of them will dissociated, okay, and get ionized to form hydrogen ion. Every molecule. Suppose there are 1000 molecules of HCl in water. So all the 1000 molecules will dissociate to give hydrogen ion. Okay. But in this case, in the case of acetic acid, this will not happen. In this, all the molecules will not dissociate. Suppose 1000 molecules of this are in the water of acetic acid. Some molecules will ionize to hydrogen ions and some will not get ionized. Some will not get ionized. A lot of molecules will not get ionized and some will ionized. So students, you have understood what is a strong and what is a weak acid. This will be a strong acid. Strong acid is such an acid which, when dissolved in water, will completely ionize, or most of it will ionize to form hydrogen ions. Weak acids are those acids where only few ions ionize. Rest of the molecules do not get ionized and give hydrogen ion. Like you see this list here, all these in this list, hydrochloric, sulfuric, nitric, hydrobromic acid, all these acids are actually strong acids. Strong acids. Especially hydrochloric, sulfuric, nitric. You should remember that these are very important acids. These three are the strong acids. Okay? And these, the rest of the acids here, these are the weak acids. You should remember that carbonic acid, which is very important, but it is very weak. Phosphoric acid, sulfurous acid, these are weak too, but it's not that important. Acetic acid, again, it is very important. You must know it is also a weak acid. Now students, we have written down some bases here. Some of these you know, some are new for you. Sodium hydroxide we have seen, potassium hydroxide, this is lithium hydroxide, this is calcium hydroxide, this is magnesium hydroxide, this is ammonium hydroxide. So these bases, all these bases, these are strong bases and these bases are very weak. These bases are extremely weak. Ultimately the concept is the same as that of acids, like when we make aqueous solution of NaOH, it is a solid, but when we dissolve it in water, then all its molecule ionize, and like this they can form hydroxide ions. But like this one, MgOH whole 2, MgOH whole 2. When this is dissolved in water, it ionizes like this, but all the molecules do not ionize. Okay, you can see another thing here. For the weak ones, the arrow is turned like this. Two arrows are made, one at the beginning and one at the end. This arrow suggests that this compound does not completely ionize to form these two elements. It does not completely ionize to form these two elements. And here we make only one arrow. This suggests that this compound ionizes completely. Okay, so basically you have understood by now what is strong and what is a weak acid and what are bases. Acid means creation of hydrogen ion. When all the molecules create hydrogen ion, it means it's a strong acid. When all the molecules are not able to create hydrogen ion, it means it's a weak acid. Similarly, the same goes for bases. So students, few things are written over here. I'm reading them out. That strong acids ionize fully in water to produce large number of hydrogen ions. Okay, we have seen that. Weak acids ionize partially in water to produce small number of hydrogen ions. The same goes for strong bases and weak bases. Okay, students, go through them. Okay, students, one more very important thing, that is concentrated and dilute. Students, if you go to a chemistry lab, you will find that these two terms are written on a lot of compounds. Like you see, you will get such type of bottle in the chemistry lab, which contains hydrochloric acid. See, in front of it, it's written CON, CON. That means concentrated. Now see students, this bottle also contains hydrochloric acid, but it's written DIL, DIL. That means dilute. So this hydrochloric acid is concentrated and this hydrochloric acid is dilute. So what does it mean, students, to be concentrated or to be dilute? It's very simple. Actually, we had dissolved this HCl into water. Okay, students? If we dissolve this in less water, water is very less water, right? So this solution, students, this is known as concentrated solution. Concentrated solution of HCl. But students, if we dissolve HCl into lots of water, the amount of water is very large and a small amount of HCl is put. So that will be called dilute. Dilute solution of hydrochloric acid. Students, as the name implies, concentrated solution of HCl, where the amount of HCl is more and the amount of water is less. Dilute solution of hydrochloric acid means the amount of water is maximum and the amount of hydrochloric acid is very, very less. When we talk about any type of acid, it might be in concentrated form or in dilute form. Suppose it's written that H2SO4 concentrated, and see here it's written H2SO4 dilute. Okay, so you will understand that concentrated means the one in which less amount of water is mixed, and in case of dilute, more amount of water is mixed. And more the amount of water mixed, we will say that the amount of dilution in this acid is increasing. Similarly, students, the same goes for bases such as NaOH. NaOH is concentrated and it is also dilute. That means in less amount of water, high amount of NaOH has been dissolved. Okay, dilute means in more amount of water, NaOH is dissolved. The more the solution is dilute, that means the amount of water is higher. So you understood that what does concentrated and dilute means. As for example, CH3COOH. CH3. This can be very concentrated or dilute. Okay. Concentrated acetic acid. This is acetic acid. Acetic acid. Concentrated acetic acid means it is dissolved in less water, and dilute acetic acid means it has been dissolved in more water. Right? See students, sometimes at the last line many people get confused between strong and weak acids and dilute and concentrated. This is confusing. Strong acid means as long as you dissolve it in water, it gets ionized completely. Weak acid means the entire thing will not get ionized completely. The amount of water is not the point here. When we talk about strong and weak, the amount of water is not the point here. When you dissolve HCl in water, it gets completely ionized, right? But whenever acetic acid is dissolved in water, all of the molecules do not get ionized. Are you getting my point? What is the meaning of concentrated and dilute? As This is acetic acid concentrated. This is sulfuric acid concentrated. That means it has been dissolved in less water. Acetic acid is dilute. Sulfuric acid is dilute. It has been dissolved in more water. Right? Now students, diluting acids and bases. To dilute the acids and bases, we mix some water. Now we will look into some more important points based on that. Now students, consider I have a beaker with me and that beaker contains some concentrated acid. Suppose if we take concentrated HNO3. It could have been any acid, we have taken concentrated HNO3. Now what's going to happen to the molecules of this concentrated HNO3? This has been ionized. This is the hydrogen ion and this is the nitrate ion, right? And what would happen to this hydrogen ion? That combines with water to create basically hydronium ion, right? Now suppose this is concentrated solution. This concentrated solution contains X number of hydronium ions. No problem. Now we put water into this and as a result it becomes diluted. Now see students, what is the situation here? Now the amount of solution over here becomes more. As we have put water, the volume of solution becomes more. Now as the water is more, it becomes dilute HNO3. Now students, tell me, if the hydronium ions were of X number, okay, so now the number of hydronium ions would increase, decrease or remain the same. What do you think students? The number of hydronium ions would remain the same, increase or decrease? What do you think? Tell me. Now students, see, the hydronium ions were coming from HNO3 molecules, right? HNO3 contains the same amount of molecules. We have added water to it and not HNO3, right? The amount of HNO3 which was there before, the same amount of HNO3 is there in the solution. Hence the number of molecules also remains the same. The number of hydronium ions is X over here. There is still X number of hydronium. It is to be noted that X number of hydronium ions were there in this small amount of solution. Okay. Now the same amount of hydronium ions is present in the same amount of solution. This more solution. Okay. So students, we can see it like if we take unit volume over here, unit volume of the solution, and if we take the same amount of volume over here too, unit volume, in both the cases, same amount of volume has been taken. So in which case, in this small volume, there will be more hydronium, or in this small volume, there will be more hydronium ions. What do you think? It is very clear that in this case, there will be more number of hydronium ions, and in this case, less hydronium ions will be present. So students, we can write that in this case, concentration of hydronium ions is more. Okay. And in this case, we can write that concentration of hydronium ions is less. Okay. Now it must be clear to you. Now another important point is, whenever we take any acid and make it dilute from concentrated, okay, then what happens? The concentration of hydronium ions become less in that solution. The concentration of hydronium ions become less. This is an important point. We will write this down here. That concentration of hydronium ion decreases on diluting the concentrated acid. The same thing goes for the bases. I don't think I need to explain more. If we have concentrated base like NaOH, then what would have happened? In that case, in place of the hydronium ions, we would have had the hydroxide ions. Then we add water to it to make it dilute NaOH. Then will the dilute hydroxide amount change? No, it would remain the same because the number of molecules of NaOH remain the same because we have added water to it. Now again students, if we would have taken a small volume here and a small volume here, then we would have seen that concentration of hydroxide ion is more, and we can see here the concentration of hydroxide ion is less. So we can write that concentration of hydroxide ion decreases on diluting the concentrated bases. So it's a very simple thing that whenever we dilute a concentrated acid or a base, then in case of acid, hydronium ion, and in case of bases, hydroxide ion, their concentration become less. Now let's see the second scenario, that whenever we add water to concentrated acid or base, it becomes dilute acid or base. So whatever the phenomena or the change occurs here, that is actually exothermic change. Exothermic. That means whenever we add water to concentrated acid, then it becomes dilute acid, and along with that, a lot of heat is produced. Similarly, in the case of bases, a lot of heat is produced. It's a very important point. And students, you can even verify this in your chemistry lab by conducting a simple experiment, that whether heat is really produced when concentrated acid or base is diluted. So what experiment you can do? Let me tell you. Suppose if you take a beaker, and in this beaker we will take water, and after that we will mix in that water a few drops of concentrated acid. Few drops of concentrated acid. Any acid can be added. Suppose if we take H2SO4, even HCl or HNO3 could have been added. So what are we doing? We are adding water to concentrated acid. So we are simply diluting that. So students, when we do this and touch the beaker, then you will feel that the beaker becomes very, very hot. So how does it become hot? Because heat is produced, which we were discussing. While doing this experiment, please keep in mind that we need to add only a few drops of concentrated H2SO4, right? If you add too much of it, then accident may take place. And why is that? We will see later on. So never do that. Okay. You can do the same experiment for base also. It's exactly the same. Suppose if we add water to the beaker, now what we need to add? A few drops of, tell me, few drops of concentrated base. Suppose we add NaOH. Now again, we are diluting the concentrated NaOH. Again, if we touch the beaker, it becomes hot. Okay. Now you can do one more thing here. See this image. This is actually NaOH pellet. I have already said that NaOH is found solid at room temperature. So this is the solid form of NaOH. That is generally known as NaOH pellet. When this NaOH is dissolved in water, it gives out hydroxide ions. We have studied all these. We can do one thing, that we take a few pellets of NaOH and dissolve it in water. Then also on touching the beaker, you'll find it hot. So this is easily proved through all these experiments that when concentrated acid or base is diluted, then heat is produced. Right? Now the third point over here, that is very important for safety in laboratory. See, to dilute the concentrated acid, we can follow two ways. One, we take concentrated acid in beaker and water on top of that. Second method can be, we take water in the beaker. See, we just reverse the first one and we slowly add acid on top. So in both the cases, water is added to the acid. Water is added with acid. So concentrated acid becomes absolutely dilute. So you can think that both are the same. We can do any of them, but that's not the point. Whenever you are diluting the acid, then you would do this and you would never do this one. It's very, very dangerous. This can be harmful to you. How? See, we have seen that concentrated acid is converted to dilute. Then a lot of heat is released. So this released heat might create a lot of problems. See what happens here. Here we are adding water little by little and acid over here. Then in both the cases, the process of dilution starts and heat is produced. But in this case, students, when we are adding water, in this case, suddenly a lot of heat is produced. Sudden release of heat. Sudden release of heat. Now in this case, students, gradual release of heat. Gradual release of heat. Heat is released gradually. This is because we have added a little amount of acid to the water. Here the amount of acid is too much. Because of the acid being much more, suddenly a lot of heat is released. But here it releases gradually. Here you can see the point of danger. If heat is released suddenly, that is not a good thing. Another important thing is this, students, that whatever heat is released here, to absorb that, large amount of water is available. Now you see here how much is the water? That absorbs the heat. The heat is being released slowly and there is a lot of water too. And this water is absorbing a lot of heat. And the temperature increases, nothing else. The heat that slowly releases here, because of that, the temperature of the water and the beaker will increase. Temperature of water and beaker increases as they absorb heat. As they absorb heat. Now see here students, the heat is released suddenly, and to absorb that heat there is just a small amount of water, a very small amount of water. And this small amount of water needs to absorb the entire heat. Now this small amount of water students gets converted to steam, and this steam comes out of the beaker. And when this steam comes out of the beaker students, it brings along with it a few drops of this concentrated acid. Along with this steam, a few drops of this concentrated acid also come out. These are acid drops. Okay. So students, you can assess the danger here. The acid drops which come out with the steam, they can fall on your face, body, or on clothes, which might cause damage to you. That's why we should never ever do this, but do it this way only. People face problem in remembering whether this one is right or this one. It's very easy students. I'll tell you a trick. In this case, we have used more water and acid is less. So more water means safety. More water and less acid means safety. Here acid is more and water is very less. That means danger, danger, danger. Okay students, this way you will remember that in the laboratory we have to do it in this way. So whatever concept which we saw here, we will write it down. See students, always add concentrated acid to water. Okay, not water to concentrated acid. When concentrated acid is added to water, this thing, heat is released gradually. Like we saw, this heat is absorbed by large amount of water to increase its temperature. Okay students, this is what we saw. When water is added to concentrated acid, like we saw here, heat is released suddenly. This heat vaporizes small amount of water to steam. This steam splits out with drops of concentrated acid, which can fall on our face or clothes and cause us harm students. In fact students, I'll tell you a couple of things that here sometimes such huge amount of heat is produced students that this beaker can break also. Beaker can break, and this is even more dangerous because if the beaker breaks, then the entire acid will spread. And that can fall on your legs or hands, anywhere students. So this is actually a very dangerous thing. So never do this students. In fact students, even when you are doing this, even then take care. Not that you put huge amount of acid at one go. Slowly you put the acid, drop by drop. Slowly you have to put the acid, drop by drop. Drop by drop. And students, as you are putting acid, you mix it with a stirrer. Mix it with a stirrer. Okay? You mix it with a stirrer. So that whatever acid you put, it mixes with the water. If you do these two things, then it is even safer students. So, how will you make concentrated acid dilute students? Take water in a beaker, then drop by drop put concentrated acids. And with this stirrer, you will keep on mixing it students. And students, what we have discussed for acid is true for base as well. Even with base, you will do the same. That in water you will put concentrated base. You will not put water in concentrated base. So I hope students, this important point of safety is clear to you. Okay students, presence and taste. Now this is a very important section of our chapter. See students, first we will talk about acids, then we will talk about base. You have seen we are following the same pattern in this chapter. Students, see, these are some edible things. One thing is common in them. All these things here are sour. Students, take lemon juice or oranges or tamarind, grapes. All these are little sour students. Even curd students, if you leave for 2 to 3 days, it turns sour. Tomato has a sour taste. Even tomato ketchup has the same. So students, in all these edible things, the sour taste, from where does it come? Very interestingly, that comes from acid students. In all these things, there is an acid, because of which it gets this sour taste. Because of which it gets this sour taste. Apart from this students, you see this is an ant. When an ant bites students, you might have seen a wound forms on your skin. Basically when it bites, then it injects an acid from its body into our body. It has an acid in its body which it injects into our body, because of which there is irritation on our skin. See this knitted plant. See this knitted plant. Leaves of it. It has tiny thorns. If you touch them, through that an acid is transferred to your body. and you'll feel very uncomfortable where you have touched this leaf. Okay, students. So I want to tell you that naturally in nature, acid is found in many places. Naturally in nature, acid is found in many places. I'll give you a list, students. Orange and lemon. In this, students, an acid named citric acid is found. Tamarind and grapes. In this, tartaric acid is found. Curd and sour milk. In this, lactic acid is found. In tomatoes, oxalic acid is found. In ketchup, acetic acid is put. In vinegar or sirka, you have seen, students, used in kitchen. This has acetic acid. And sting, we talked about it, has formic acid, also called methanoic acid. In Newton leaves, also the same acid is found. So students, two things to be noticed here. First is that the sour taste which all these things get, all these things gets it because of some acid. Apart from this, there are many edible things which are sour. They also get the sour taste from some acid. From this, we know, students, how is the taste of acids? Sour. Second important thing, students, that many of the acids exist in nature. We don't have to prepare these acids because they are found in nature. But some acids, students, like HCl, hydrochloric acid, sulfuric acid, then nitric acid, carbonic acid, its name you might not remember as we have not discussed it, carbonic acid, H3PO4, this is also an acid, H3SO3, this is also an acid. All these acids, students, are not found naturally. We make these, students, we make this. So such acids which we make, students, are called mineral acids. Mineral acids. Why mineral acids? Because they are made from some mineral. And these which we get naturally are called organic acids. Organic acids. So students, we can define that organic acids are acids found in plants and animals. In plants and animals, we get them naturally. Mineral acids are acids made by man. From metals. Okay. So students, very clear difference. You might have understood. One more interesting thing, students, that all the organic acids are weak acids. Each one of them are weak acids. But the mineral acids, students, can be weak also and strong also, like these three here. Very important mineral acids. They are very strong acids. But these three here, carbonic acid and these two acids, they are weak acid, students. So very important to note that organic acids are always weak, but mineral acids can be strong as well as weak. One more important thing, students, these acids here, we sort of eat them because they are actually in our food. But students, in general, acids are very harmful to us. Like HCl, H2SO4 or HNO3, these acids, you will never put them in your mouth, students. They are in the lab. Never try to taste them, students. Your tongue will get burned, students. It will cause harm. But these weak acid, students, are in our fruits and vegetables and in dilute form. Firstly, they are weak, and on top of that, they are in dilute form. That's why there is no harm in eating them, students. This is a weak acid. Even this. This is found in Coke. Thumbs up. Pepsi in dilute form. If we take weak acids in dilute form, then there is no problem. But strong acids, we cannot even think of tasting them, students. That will be very dangerous. So students, we can write here, we can take dilute weak acids in our body, and we do take them. Even then, students, in the lab, you will never try to taste a weak acid that is dilute. If you have to do anything with that, you want to do anything, you will do it in the presence of your teacher and only after consulting them. Because sometimes even weak acids are harmful for you. Now, students, we will talk about bases. What are some commonly found bases, students? See, soap and detergent, which we use in our day-to-day life. In that, these two bases are found generally, sodium hydroxide and potassium hydroxide, students. Then in batteries also potassium hydroxide is put. The whitewash which we do in our houses, in that calcium hydroxide is there, which is also a base. Many times in edible things also base is there, but it is not found that much in edible things like acid is found. These are some places where bases are commonly found, students. And students, I will tell you that bases have a bitter taste and have a slippery feel to them. Slippery feel. Like if we talk about soaps, then mainly it has bases. So, soap is slippery. And you can also taste it a little bit. It's not be harmful. And if you taste a little, then you will get a bitter taste. Okay, so this is about bases. This was the basis. Conduction of electricity. So students, the solutions of acids and bases, electricity can flow through them. Very simple thing, students. And to prove this, we can do a simple experiment in the laboratory. See the set. A simple setup is there. You have this beaker, you see. Below that you put a rubber cork. You see we have put two iron nails there. From this iron nail through a copper wire we have connected a battery, students. Okay. To connect circuits, copper wire is used. You might know this. A 6-volt battery is put. A bulb is put and a switch. And then we connect it to the other nail. When you switch it on, this bulb here starts to glow, will glow. So what does this glowing bulb tell us? It's telling us that the circuit we made, current is flowing through that. Current flows. We will see how the current flows, students. Current will have come from this battery, through this bulb, through this switch, through this copper wire. Current reaches till this nail. From this nail, how it reaches the other nail? What is in between? Dilute HCl solution. So this means, students, through this dilute HCl solution, electricity flows and reaches this nail. From this nail to this copper wire to battery to the bulb, it reaches, students. So the glowing of this bulb shows that this dilute HCl solution in between, through that electricity is flowing. Okay, students. So students, here instead of HCl, if you take H2SO4 or any other acid solution, even then this bulb will glow. In fact, even if you took a base solution like NaOH, KOH solution, even then you would see the bulb glow. This means, students, all these, the solution of all conducts electricity, students. Why does it conduct? That also you know. If we talk about HCl, students, we have HCl solution, means HCl in aqueous form. It makes hydrogen ion plus chlorine ion. This hydrogen ion, we know that it gets converted to hydronium ion. Hydronium ion. Okay, students. So this means that the solution, this solution of dilute HCl, in that basically we have hydronium ion and chloride ion. Chloride ion. Chloride ion. So these ions, students, these ions, they can move in a solution. And because of their movement, electricity is conducted. These ions means chloride ions and hydronium ions, can move in the solution to conduct electricity. Similarly, students, if we have other acids, with them the same thing happens. If we have a base, suppose KOH, when we have its aqueous solution, what happens? Potassium ions and hydroxide ions are made, and these ions once again will be able to move in the solution and will conduct electricity, students. You understand it? So students, we will write this. Acid and base solutions can conduct electricity due to formation of mobile ions. So acid and base solutions are called electrolytes. Acid and base solutions are called electrolytes. Electrolytes mean they are such solutions through which current can flow, through which electricity flows. Okay, this is an important term. You should remember this. Okay, students, a very good question has come to my mind. Here the solution which we took dilute HCl. Now suppose in another case we take another acid, dilute acetic acid. Dilute acetic acid. In both these cases, once when we took dilute HCl and once when we took dilute acetic acid, the bulb which glows, what difference you will see? Think and tell me. What difference can you see in glowing of the bulb? Students, you might have guessed that dilute HCl, that time the bulb will glow brightly. And when we use dilute acetic acid, it will glows dimly. Why does this happen? Why? Can you think and tell? See students, try to remember that dilute HCl, that is actually a strong acid. It is a strong acid. And acetic acid is a weak acid. What happens in this? Now, HCl is a strong acid, students. So all its molecules will ionize and make chloride ion and hydronium ion. That's why when we take HCl here in this solution, there will be many ions, because all the HCl has ionized. But when we take acetic acid, students, it is weak, so it cannot completely ionize. So in this case, less ions are there in the solution. In this case, more ions. Strong acid ionizes completely, more ions. Weak acid does not completely ionize, less ions. So now students, it's clear. When we take HCl, so more ions are there. More ions will conduct more electricity. So bulb will glow brightly. But when we use acetic acid, it's weak acid. So less ions are formed. So electricity is conducted less. Because of which bulb will glow dimly. I hope you understand this. Right? Okay. Here, one interesting thing that we should talk about, students. If I write formulas of some acids, HCl, H2SO4, HNO3, H2CO3, carbonic acid, many more we can write like CH3COOH. This is acetic acid. We spoke about it. Students, we spoke about it earlier, and you can see in formulas of acids, there is hydrogen for sure. Hydrogen is there for sure. See, does this mean that in any compound, if you see hydrogen, then it is an acid? Like you see hydrogen in any compound means it's an acid. Like C6H12O6. This is glucose. This also has hydrogen, students. Glucose. This is glucose. It has hydrogen. So is this an acid? No, students. This is not an acid. Every compound which has hydrogen is not an acid, students. Such confusion happens that whichever has hydrogen is an acid. It's not like that, students. We can write all compounds having hydrogen are not acids. Like this glucose. This is not an acid because, students, if we dissolve this in water, when we dissolve this in water, this does not produce hydrogen ions. All these are acids because when we dissolve them in water, they produce hydrogen ions. When this is dissolved in water, it does not produce hydrogen ions. That's why it is not an acid. So the criteria to be an acid is not that hydrogen should be there. The criteria to be an acid is that hydrogen should be there, and when we dissolve that substance in water, so hydrogen ion should be produced also. Okay, students. That's why glucose, though having hydrogen, it's not an acid. Like this, there can be many compounds, students. We can prove this experimentally also, that no ion is formed. When we dissolve glucose in water, no ion is formed. For that, what we do, we took here dilute HCl solution. There you take glucose solution. Here if you take glucose solution, students, you will see that the bulb here will not glow. No glow. Why so, students? Because this solution is not able to produce any ions. And because there are no ions here, so electricity will also not be conducted. Right? And if electricity cannot be conducted, so bulb will not glow. With this experiment, it can be proved that glucose does not make any ion after dissolving in water. So students, here we can write, if glucose solution is used in this experiment, in absence of ions, electricity cannot flow. So bulb does not glow. It also proves that all the compounds having hydrogen are not acids. Okay?